So I worked on a project recently. I think it took me about a month to do. And I went from something I needed, an idea stage, to outsourcing PCB to a manufacturer. So I'm just going to talk about my problem, my idea, and how I went through solving. And I'm going to compare two manufacturers that I found for a PCB board making. So my problem is I have this robot that uses 2 steppers and 1 servo. And usually these shields are sold for CNC machines, which have 3 steppers. So my problem was, like, I wanted to use the shield and not make a new one, but I also needed to use the software that somebody wrote for interpreting G-code and not modifying G-code or the hardware, but also switching to one of the signal outputs to servo output. So that's what I did. So I had several ideas, like I could modify the actual software, but I thought it was a bad idea because if they come out with a new one, I would have to modify that one. I can modify G-code, but I think that's a bad idea because G-code is pretty complicated language. In case you don't know what G-code is, it takes a vector and it converts it to like coordinate system that you could use to command stepper motors and draw a bunch of stuff, or use a CNC or a 3D printer. So I didn't want to modify G-code because that's kind of a little too much, I guess. And then I can make my own board, but that requires a lot of time and effort. And since we're in Hackerspace, I wanted to do something hacky and quick. So my idea was to take this 18-tiny little chip, program it, and it would convert the stepper motor signal from the hardware into PWM signal, which is what Servo uses. And here's the pros I already mentioned. So this is how signal looks for stepper motor. So you have a step that has some interval, and then you have a direction. So it's like you have like 2 pins that output some kind of signal, and then the servo, it has only PWM, and the way it controls like what position it's in, it's by duration of the pulse. So it's only 1 pin, and it has like 1 signal that it sends. The first step is breadboarding. So one of the members, Ian, helped me program the chip. So he wrote the code, and we used this guy to program the actual chip because you can use it through Arduino, but it's kind of a pain. And I think this was only $20, and it was pretty reliable, and you could just, pop the pin in, program it, and put it back on a breadboard. And this is like, so here's my setup, and I used there's a servo somewhere. So once I tested it and we figured out like that the code works and the hardware works, I went from a breadboard to a handmade board. One of the problems was I wanted, so if I go back really quick. So here you put stepper motor drivers that control the current, and they fit into these little slots. So I wanted my handmade board to fit in the same slot. So the drivers, they were like really tiny. So I made a really tiny handmade board. And it took me about 3 hours sitting there and soldering all the pins and trying to figure out which connection to connect. And I used a multimeter a lot to see that nothing touched. And as you can see, it doesn't look pretty, but it works. And so that's my handmade one. Then I used KICAD, because there's no way I want to make any more of these, and I need about like 10-ish. So I used KICAD thanks to Eddie. He showed me how to use it. And first you start with just the outline. So this doesn't have any physical meaning. It's just like how the circuitry connects together. And then you go to the next stage where you put physical connections. So this is these are just male pins. This is like a servo pin. And here's some capacitors. And this is where AT-Tiny would fit. So I would have to myself solder the connectors, but the board would be made. And in KICAD, you can draw your own traces. So like the red is the back layer, and the front is the front layer. And it's like a 2-layer board. For space, it's pretty good. And And then I found 2 manufacturers. So Eddie and Joe, they use these guys, and they're based in China, and their website is really nice looking. So you could get 2-layer board for $5, and you get 10 of them, and you pay $20 shipping, so it comes out to $2.6 per board. And it takes 2 to 3 weeks. And then this guy, this is an American. I think they're based in Ohio, and they're a lot cheaper, but you only get 3, and it's also the same lead time. And their website kind of sucks. I don't know why. It's just like it seems silly, but I think I'm gonna go with them because they have really nice. You can submit your files from KICAD, and they show you how it's gonna look. And this is like what they promise my board will look like if I get it in time. So I think I'm gonna order from them. So yeah, that's about it. The end. Question.
So the AC Tiny, is that program? Do you program that using the Arduino IDE and all that, or is it a different programming language?
It was like a different programming language.
Okay.
But I didn't program it because Ian did it, and he just, I don't know.
Do they have board size limits
For
their prices? Or like, does the price increase according to the size of the board?
Are you talking about the programmer?
From the website.
Oh, just for the manufacturers?
Yeah.
Yeah, usually, so for this one, so Joe had like this big of a board, and it was about the same price. And then if you want more, it kind of goes up by $5. Okay. And same with these guys, it's like 5, increments of 5, the bigger the board gets. So I think it's actually pretty cheap, so you don't have to do like handmade stuff, because that's like took me 3 hours, and I was like resoldering these pins, and like it's all melted, and then I had like a wire like 3D effect, like, you know, it just like vented.
The garage boards.
Yeah.
Since the board is about what, 4x3 or 4x4, can you print multiple? Could you have them basically print out multiple of your stepper to servo drivers on that 4x4 PCB, and then you just break it out?
So
just doing just one on each.
So you can manufacture in 2 ways. You can do etching, and these I think they might use like a CNC machine or some kind of special machine, and I'm not really sure how they do it. I never been to a factory, but I know there's a company called Off the Shelf, and it's based in Gainesville, and they make these little microcontrollers for UF to use. And they have a machine that it takes a PCB board, and it can lay out like little pieces, and it looks pretty cool. But it's kind of semi-standardized, so you can't do too many things.
You probably specify multiple iterations on it, but one of the ways that they make it really cheap is they put your design scattered around the edges of other ones they're doing. So it probably works out better for you to just make the size you actually want.
I mean, if they told you you get this 4x4 inch, then you could probably use KICAD to plop out a couple of them on that 4x4 and hand it off to them. Because if they're only going to charge you $3 for that 4 inch, maybe you can get more in that 4 inch space.
Well, so the thing is, it's like how do they lay the copper? So I'm not sure how they do that. And they might have a setup where you put one board and they like stamps it or something.
Yeah, it might be.
So it might be, I don't know. That's a good question.
It's not bad. You can put. Yeah, that's what I'm saying.
Yeah.
You can put
I like that.
cuts in like put the top and bottom layer runs on the edges, so that when it actually runs it, then you just snap it off. I'm thinking about doing the exact same thing. That's why I'm asking.
Okay. Well, there's a guy who.
Something on the website too.
Yeah.
Yeah, I mean, I would check them out because I don't want to do the handmade ones, but so if you want the complete board, like soldered and everything, this is like $100 or up. So I'm like, I just want the nice looking board. I mean, this looks pretty cool. And all I have to do is, so I have to put the AT Tiny chip thing, nail the male connectors, and 2
Surface mount
capacitors.
capacitors are not easy.
So, okay,
Surface mount anything is not easy. Get a it can be if you have the right tolerance.
so I was like, hey Eddie, should I use them? And Eddie was like, yeah, you should, because the signal travels through the male connector. It might there's some weird effect that kind of might short it. Not short it, but just lose power for a second. So the capacitors help not do that. So I'll find out, I haven't ordered these, so I'll find out how easy or not easy the little.
Fine.
I mean, if I did this, I feel like I'm okay.
Yeah.
This is less than an inch. This is a 0.5 by 0.8 inches. So I started very happy and I got all my diagrams figured out, and then 3 hours later this. Yeah. But if it's within my CNC shield, so I don't have to change the CNC shield, I could just plop it, and then I don't have to change the software, and I have to change the whole board, and then it works the way I want. Yeah. The end.